Hi friends, in this video we are going to learn about how to implement 8x1 multiplexer using 4x1 multiplexer. Already we have seen in the previous video that number of lines available and what are the marks we need to use and how we will use. In this video we are going to learn how to implement using 4x1 marks. This is considered to be a important case, a special case. We will see why it is called a special case now. So the table will remain same either for 2x1 marks or 4x1 marks. Okay. The thing will be changed is number of lines available here are, as it we are using 4x1 multiplexer, it will be 4 input lines we are using. Okay. Now it is n1 equal to 8. So we need 3 selection lines. 3 selection lines. Okay. Now the same thing, divide 8 by 4 we get 2, divide 2 by 4 we get 0.5. So we need to use a 2.5 muxes. That means in the third mux we are going to use only few input lines, not all the input lines. Okay, that may waste some memory, that may waste the power. So what we'll do is we go with only 2 muxes and we'll see how can we arrange 3 selection lines instead of 4 selection lines. Okay. Now we consider 2 muxes of 4x1 size. As we know, it is a 4x1 mux. Input lines are 4, so we have 2 selection lines. Okay. Now it has 4 input lines. I0, I1, I2, I3, I4, I5, I6, I7. It has only one output line. Now suppose I need I0 to be the output of both the muxes. What I should do? Here actually for implementing this we need only 3 selection lines, but we have given 4 selection lines. So instead of going to this using 4 selection lines, what we'll do is we'll take another pin called enable pin. So for any device, if enable is on, then the device will work. If enable is off, then the device will be off. Okay. Now consider this enable pin. What I will do is I will give the complement of the enable pin to upper one, and I provide this enable pin to one of the selection line. Okay. So what happens is, consider the selection line as I consider the selection line S2 here, S0 here, S1 here, S0 here, S1 here. Okay. Now I need I0. As you can observe, for the first 4 selection lines S2 is 0, and for the next 4 selection lines S2 is 1. So when I want I0, S2 should be 0. Zero, 1, 2, 3. Okay. Now why S2 should be 0? Because if S2 is 0, then only this mux will be on, because when it is 0, its complement will be 1, and this enables this device to work, and when S2 is 0, enable is 0, so this device will be off for the first 4 selection lines. Now when it is on, and when S0, S1 is 0, 0, we get the output as 0, 0. So this should be 0, this should be 0, this should be 0. Now the output of this is, when device is off, the output is 0. The output of this will be I0. Okay. But as we're using two muxes, we will get two outputs. So to render that, what we'll do is we use a OR gate. We use an OR gate as well for output. So now we get output. So why we're using OR gate is it adds both the outputs of the multiplexer. As we already know that for the first 4 selection like this will be on, for the next 4 selection this will be off, for this will be on. So output of both, if we add, we get the same result what we want from the input side. Okay. This is how we implement 8x1 multiplexer, 8x1 multiplexer using 4x1 multiplexer using enable pin. That is why it is considered to be a special case. Okay. Now